a lot of kids struggle with that. And I'm gonna teach you guys a little tricks to apply. We're gonna focus on one part of the science section today. So each lesson, we're gonna take one part of it because there are 3 types of passages. So we're gonna break each passage down, each type of passage that is addressed in the science section. And we're gonna analyze that particular passage and understand how to work that particular passage. And then we'll go through each of those passages before we bring them all together. That way you guys be kind of sort of prepared for that. All right. Anybody else? People just chilling and quiet, right? All right, so I guess I'll go ahead and go to into the PowerPoint. So can you get everyone see my screen? Is everyone able to view?
Yes.
Yes.
So for the ones that do not know me, I'm Coach Reese. I teach at Grissom High School, and I am a science teacher. I teach chemistry and physics. Even outside of CAP&GOWN, if you guys are struggling with some of your science stuff, need some help, don't hesitate to say, Coaches, can you kind of help me with this? I don't mind helping. I'm a hands-on teacher, so I teach very hands-on. So I have a different way of explaining things to my students, and typically my kids kind of like that. But it requires a different type of approach. All right. So, but yeah, I'm Coach Reese, and so today we're going to be doing the ACT science section. And we're going to focus mainly on today. We're going to focus only on the data representation section. So, what do you guys think? What do you guys think data representation is? What comes to mind when you hear data representation?
Like those, those charts, and it has like the percentage and stuff like that.
Mm-hmm.
And you have to answer the question based off the chart.
So so any type of chart. So we talk about data. So when we think about as in science, someone is going to do some type of experiment, and this experiment is going to render data. The way that we address the data in science is by analyzing charts. We look at the charts. So we should be able to look at the components of the charts and identify those things. So if I ask you to look at a chart and to identify certain things, what must be on the chart? What must the chart have?
It should be labeled. Like if it's
labeled. All right. So you want to look for some labels. What else? What else did you expect to see on a chart? What would the label say? Like what kind of labels would you expect to see?
Maybe like the different numbers.
Like the different numbers. All right. So the different numbers. Okay. See the different numbers. What else? What else do you expect to see there? Like what it should be something about what do the numbers mean, right? And anytime we talk about, we look at some type of change. So when we talk about the science section, there are 3 different types of passages that you're going to deal with, and they all have some type of data. But the data representation section, it is strictly going to focus on how data is represented and how you analyze the data that's represented. And when we look at graphs as scientists, sometimes we can look at things to get direct information, and sometimes we must interpret the information based off of trends. So you must be able to look at the trends that are exhibited by a certain graph. So the science section is 40 questions, and there are 3 passages, and you have 35 minutes to read through these 3 different types of passages, summing up a total of 40 questions. And here's the thing. The reason why a lot of kids typically don't do well in the science section, one, is the last section. So by the time you get to the science section, you're just like, okay, man, I'm ready to go. Like I'm over it, right? So don't let the anxiety of ready to get out of there kind of help you rush through it. And this is one of the most unfinished sections of the ACT. I'm an ACT tutor, not tutor. I'm an ACT proctor. I gave the ACT last week here at school. So I'm certified through ACT. And when I tell you, as I'm proctoring the exam, as it got to the science exam, I noticed where, kids just looked so burnt out when they got to the last test. They're like, man, I'm ready to go home. And I can witness that, kids weren't really doing, giving the same amount of attention to that particular section of the test as they had done in the previous sections of the test. So definitely don't let time get over you. So, you'll have 7 different passages. and you'll have 40 minutes to complete these 7 different passages. And of these 7 different passages, they're going to be 3 different types: data representation, research summary, and conflicting viewpoints. And data representation is typically the easiest of any of those because you're going to be given some type of graph, and it's simply you looking at the graph and analyzing the graph. And generally speaking, most data representation is going to come with some paragraphs, right? This is how you tackle the science section, right? Because all the data is there. Essentially, you want to read the questions first, because you can read the questions and you can look at those graphs and apply the information just from the graphs. Because sometimes you'll waste your time reading through the passages and they're not there. So you want to skim through the passage, but definitely. So the first thing you want to do, you want to kind of look at the charts and just kind of like analyze the charts and then read the questions. Because when you analyze the charts and you start to read those questions, oh, this is asking about pH. Oh, this is asking about the temperature change over such and such. Oh, this is asking about how does the effect of this pH affect the overall change in the incubation period of X, Y, and Z. And so you want to kind of identify what factors and what variables exist there. All right. Unfortunately, on this section, there's no calculator on this particular part of the test. So the math that is included is very minimal level math. Typically, if you have math to do and they ask you to calculate some things, it's things you can do as far as mental math. All right. So we all pretty decent with mental math, with basic math.
Yes.
All right. Good. All right. So when we talk about the ACT science test, the basic things that we're going to deal with. So what it covers basic biology, earth and space, physics, and chemistry. And so kids are like, oh man, I don't like chemistry. I don't know about biology. Well, although it covers these contents, you don't have to be proficient in these contents. Why? Because all the information you need is going to be given to you. And so every single question that you're asked about can be given to you by the information that is present. And so we call the science test a science reasoning test. So I'm going to provide you some type of scientific data, and you're going to use your scientific reasoning skills to analyze, to recapitulate, and to select the correct answer. All right. And so of the 3 types of passages, this is how the breakdown is written. You'll have 3 passages that are data representation. You have another 3 passages that are summary, research summary. And then you have 1 passage that is conflicting viewpoints. All right. Now, when we talk about this, it won't be listed, oh, data representation. All right, that's not, so you just have to be able to recognize. I'm going to teach you how to recognize these different passages, because the way that we tackle these passages are different. If you learn how to tackle each of those passages, when you recognize them, you can switch up here, you can switch it up, and you can kind of handle that passage for what it's worth and move through it pretty quickly and effectively, getting great results in that section. All right. Any questions so far? All right. Any questions so far? Yeah, I got to talk to man. I don't like saying like I'm talking to myself. All right. So the data representation. So when we talk about data representation, so data representation passages, they contain 1 or more figures. So you're going to have some type of figure. So some type of image. That can be a chart. It can be a graph. It can be a table. It can be a snippet of some actual research. It's going to be some information there along with the passage. And there are going to be 5 questions based off of how well you can understand the information that is present in the graphs in those data tables, right? So essentially, you have to be able to read and analyze graphs, right? And you see this, there's no heading for this section. So it's not going to tell you that, oh, this is data representation. When you see graphs present in this section, you should be, oh, these are graphs. There's some tables. It's asking about graphs, tables, and charts. This is data representation. So anytime on the ACT where you are addressed by actual data charts or graphs, you should be able to identify that as what kind of problem or what kind of situation.
Data representation.
All right. It's a data representation. All right. Oh, why is it doing that? There we go. So let's talk about how do we interpret this thing. So when you look at a graph, you want to look for ideal things, right? So the first thing, what is the graph relating to? What is the topic of the graph? What are we focusing on? And that topic, you may know something about the topic, you may know nothing about the topic, but however, it will allow you to have the understanding of what's going on. It will kind of give you a general synopsis. When you think about the topic, what do you guys generally exist inside the topic of a graph?
what the graph is about?
What the graph is about. So essentially in science, we call those the dependent and independent variables. So we talk about what variables are going to be affected. Let me pull up something for you really quickly. This is something I was just, okay, yeah. It's crazy. We're doing graphs in my science class right now. They have to do all their graphs by hand. I mean, in Excel, and we plot those graphs. So here we go. Here we are. So if I was to show you, are you seeing my screen?
Yes.
All
Or
right.
it's just still on the little PowerPoint.
Okay, let me go back. Share. Let's stop share. Let's go to a new share. Here we go. And I want to share that screen. All right, are you guys seeing this graph that I have on the screen?
No.
No.
I'm gonna get it. Give me 1 second. Oh, I gotta click that. There we go. What about now?
Yes.
Yes.
All right. So when you look at this graph, right? So here's the title of this graph. So based off the title of the graph, I should be able to identify that I'm looking at a relationship between what two things? Just off the title of the graph.
Mass and volume of distilled water.
All right. So it's telling me I'm looking at a relationship between how the mass affects the volume of distilled water. All right. And so graphs have axes. You have your x and y axes. So I'm looking at how. Do you guys know how to identify or pick out what part is the x and the y axis? How do we come up with the labels of the graphs? All right. So if you ever have a graph that has this is what we call the linear graph. All right. So this is a linear line. And anytime you have a graph that has something versus something, right? A linear graph is going to give you the slope, right? So we talk about rise over run. So it's always going to be your y versus your x, or whatever item or whatever entity you're dealing with. So we're talking about the relationship as y increases. How does that affect the x and of the distill of this information of the distilled water? All right. Any questions, concerns, comments, smart marks? All right, I'm gonna go back to the PowerPoint. All right, so the topic of the graph is there. You wanna look at what variables exist on both of those axes. And looking at the variables on the axes, again, we talk about identifying the x and the y axes. X is horizontal, it's what's gonna go left or right, and vertical is what stands up straight. And you want to look at what units are attached there. So every time you have some type of graph, that is going to have the units that is attached with the variable. So the variable is what you're dealing with. So on the last part, which is the last image I just showed you, what were our variables? What were the variables on the last one? See if you guys are paying attention.
Are the variables the mass and volume?
The variables were mass and volume, right? What were the units of those variables? Pull it back up for you guys. This it? No, that's not the one I need. What are our units of stop share? Let's just go to share the entire screen. That way I don't have to go dibble and dabbling. There we go. All right. Can you guys see my screen? All right. What are my units of my variables?
Grams and milliliters.
Grams and milliliters. So you can look at all that and identify the information. And it says if there's a key there, so typically the key is there if there are two more lines on a graph. And what will happen is it will tell you, it'll help you identify of the two graphs, which line represents which series, right? And so if I wanted to insert another series in this graph, well, I can't do it here. But if I was to insert another series, it'd be on the same graph and it may be a different color. And on the side, I say, well, the blue dot, the blue circles equals series 1. Or I say, or maybe the next line may be a set of triangles, and it'll give you that. It'll be a key that will kind of give you guidance of what you're actually dealing with there. All right. And so when we talk about these, we want to talk about the trends, right? And so you want to compare each of those axes to one another, and you want to discuss the relationship. So what happens to the x variable as I increase on the y variable? What happens to the y variable as I increase on the x variable? Is there any change? Is there anything that's consistent? So let's look at this graph here, right? So if I look at these numbers, let's look at X, all right? Here's my X variable. From left to right, as if we were talking about, if we continue increasing the time, right? What will happen to the volume as time goes on? Does it increase or decrease from left to right?
Increase.
It increases, right? Well, let's talk about it in terms of mass, right? So if we can take mass in terms of time, say, okay, the longer someone sits here, the heavier they'll become, right? As time goes on, what would you see as terms of their mass? Increase or decrease?
Increase.
Increase.
Increase, right? So now let's bring this into focus of this particular graph, right? So tell me, as the mass of the distilled water increase, what happens to the volume of the distilled water?
It increases.
It increases as well, right? And so that is a relationship. So when you talk about relationships in science, we define relationships as being either directly proportional or indirectly proportional, all right? You guys ever heard those terms? Another term of
No.
indirectly be inverse proportional. All right. So if something is inverse or indirect proportion, that means as one increases, the other one is going to decrease. And generally speaking, if you have an indirect or inverse proportion relationship, that is not going to give you a straight line. It's going to give you a curve. So it's going to look something like this. All right, if I was to go to Excel, all right, let's open up a sample data. All right. Let's say I want to highlight this data here. All right, and I want to insert a graph. Insert chart. And so we talk about something that will be inversely proportional or indirect proportional. It looks something like this. All right. So you see this curve. All right. So this is showing that as well, actually, let's do one that's a little bit better. All right. So as I move, something is increasing, but as I go over, something else is decreasing, and that's just an ugly graph. I need some better data. We'll go with this one. And so we talk about the relationship that is there, that exists there. So generally speaking, you should see an increase from left to right. If it's not increasing from left to right and it's going at a decreasing function, then we're talking about something that's indirect proportional. So they should be consistent with one another. If they're direct proportional, if they're indirect proportional, you should see where one increase, the other one's going to decrease at the effect of one axis on the other. All right. So questions that will come up about graphs like this, it will be find a particular point on the graph, identify the trend. Remember, talking about identifying the trend, it's talking about whether it's direct proportional or whether it's indirect proportional. Interpolation, right? And so that's when you take 2 points to add a point to two of the known points. So you kind of figure out, okay, what happens between these points, between point A and point B. What happens to the numbers? Is there a studying consistency? Is there a change and is there a pause? Does it increase? Does it decrease in those values? Does it double? Does it triple? Does it decrease by half? So you want to look at those factors in that sense too. All right. And so and so instead of interpolation, your extrapolation, which is the opposite of that, you want to extend that graph. You want to say, okay, even though there is no point on this graph, you want to predict what will happen. So although there's no point here, right? I can say, okay, what would you guys expect to happen to the mass of this particular distilled water if I increase the volume to 12? Like what value would you expect the mass to increase to if the volume increased to 12 milliliters?
12 grams.
12 grams, right? And so even though it's not plotted on the graph, you should be able to say, okay, rise over run. Okay, if I'm talking about what would the mass be at 12, go over here, find it along my x-axis. On the x-axis, it lines over 12. So if the volume increased to 12, it should read out to 12 on the mass, right? It won't be anything direct like that. It'll say, okay, what happens? What would you expect to see? What would the volume be if the mass increased to 11 grams, right? So there's no dot there at 11, right? We want to talk about what will happen between those 2 points, right? And so we're talking about what happened between 2 points. So when at a point between two known points, that's interpolation. So you want to figure out, okay, between two known points, what will happen here? So a question would say, okay, if the mass increased to 11, all right, what will happen? So between 2 points that we have here, or we may say between 8 and 10, what would you expect the mass to be if the volume was at 9? So there's no 9 there, but you can, let's go to draw. You can visualize, or you can actually write in your ACT, you can visualize, okay, if I put a line here, if this is 6, I said 9, then we're going to make it 7 because I'm already drawing my line, all right? If this is 6 and this is 8, the number between it has to be what? Has to be what?
7.
7, right?
7.
And so we read graphs the same function, all right? So I find 7 on my x-axis. I figure out where they are related to on the y-axis. All right. And so my volume is at 7, then my mass should be at 7 as well. And so we're picking between 2 data points. And we'll also talk about when there's no data point, you're going outside of that region. All right. And then you want to define the relationship between the curves. When we talked about relationships, to be defined as what? Relationships can be defined as what, ladies and gentlemen? I'm talking to y'all. How we define the relationship? We just talked about if they are increasing respectfully one another, we call that what kind of relationship? Directly proportional. All right. If they're not increasing with one another, we call that inversely proportional or indirect proportional. One is increasing, and that's one variable increase, the other one decrease. That is inversely proportional or indirect proportional. Those are interchangeable words. But if one factor increases and the other variable increases at the same rate, they are directly proportional. All right. Let's look at one. All right, so we're going to talk about interpreting the graph. So I want you to tell me what variables exist here and what are the units of this particular graph?
You have height and distance and feet and miles.
All right, so what is in height? So you say height is in terms of
Feet.
All right, and miles is in terms of
Distance.
All right, or vice, or your distance in terms of miles. Both of those are the same thing, right? So what information can you gather from the key of this graph?
We have different speeds for the data in the graph. We have 3 different speeds.
We have different speeds, right? So based off of the key that we have here, we can identify the speed of each of these lines, right? Based off the color key code as it pertains respectively to the data charts. All right. All right. So we want to talk about the relationship, right? So the relationship we can identify. So we want to talk what happens to the distance, right? So as the distance increase, how does that affect the height? Oh, sorry. As the distance increase, how does that affect the height?
It increases and then decreases.
All right. So when we generally speaking, so it increase and decrease. So when you talk about this, generally speaking, if they have a question that says increase and decrease, that's perfectly fine. If that's one of the answer choices. But typically speaking, when they ask about, when they talk about what is the relationship as the distance increase, what is it to the height? So we just keep following the distance all the way down. So we follow the green from beginning to end, right? You don't want to stop midpoint unless it gives you direct instructions. So if it says, okay, if the distance only went to 150, what would you expect the effect to be on the height? And it would be to increase, right? But past 150, what happens to that height?
Starts decreasing.
It starts decreasing, right? So the way that you will answer this particular question is as the distance increase. So we're talking about it doesn't give us a stopping point. So we must look at as the distance continuously increase, right? What essentially overall, what happens to that overall height?
It decreases.
The height decreases as well, right? And so looking at that, we say, okay, we have 3 different graphs here, 3 different lines on the same graph, I'm sorry. The 50 kilogram, 65, and 80 kilogram lines, we want to figure out they're the same until what particular point or what particular value?
50.
All right, so somewhere right about All right, so here's 40, here's 60, 50 be like right here in the middle. All right, I'll plot it right here. And I'll take that 50 because right past that point, the first part starts to branch off right about here. That way, and there, and there. All right, do you see that? Any questions so far on that?
No.
No.
All right, we'll go to the next slide, all right? So again, things you might see. Oh, I've already done this. Why is this in here twice? All right, so questions you might see, questions you might see on the particular chart. So the relationship between two sets of numbers, we call those interpolation, extrapolation. So we want to figure out what are those points. So between two sets of data, which one is the correct one? What is the relationship between two sets of data? How do we identify that? Oh, that's what the other one was a question. I'm sorry. No, that was a typo. This is the question. So how do we identify the relationship between two sets of numbers? All right. If it's between two sets of numbers, what is that? How do we identify that? Is it interpolation or extrapolation?
Extra.
All right, it's extra, right?
Extra.
We want to go in between those 2 points. All right. So let's make sure we're able to identify that. All right. So we're going to do another set of series. This is a different type of graph, right? This is not a graph at all. This is a table, right? It's a series of tables, and we want to figure out some information. So let's address the information. So the first thing is I want you guys to tell me what information can you gather from just looking at the table itself.
The temperature.
Temperature. What else?
Various units.
Various units, right? So you got different units. You have your Celsius, you have your milligrams per liter, which is some type of mass over volume. So that is a density, right? And the same thing for nitrogen. These are density values of these things. And the science, a lot of things they're going to ask you guys, a lot of things they're going to test you on is things they kind of want you to know. So always remember that if you ever see anything like something with some type of mass, all right, over some particular volume, right? And so units of mass is like grams, kilograms. You can have like a hectogram, all right? So anything with some type of gram, right? You got milligram, that means it's a mass, all right? Anything with some type of liters, so whether it's milliliters, whether it's simply liters, whether it's picoliters, whether it's kiloliters, all right? Whatever the case may be, if you ever see anything that has a unit of some type of mass over some type of volume, understand that, it's a relationship with some type of density. That may be a question that they ask you and not give any direct information, but assume that you will expect you to know the information that, hey, that's a density particular aspect, all right? What other information can we gather from the graph? Someone said units, someone said temperature. What about the pH? We can identify the pH, all right? We can look at the dissolved oxygen and we can look at the amount of the nitrates. Agree or disagree?
Agree.
All right, you want to analyze all aspects of that entire graph, right? So it says, what are the units and their variables of those particular units? We've identified the temperature in terms of Celsius. pH doesn't have a unit. Dissolved oxygen has units of milligrams per liters, which is what?
Density.
Density, right? And then nitrates have a value or units of milligrams per liters of nitrates. Is simply that's nitrate, and that is also a what?
Density.
A density. So just make sure you're thinking about those in terms of that. All right. All right. So it says, what is the relationship between dissolved oxygen and temperature? So what is the relationship between dissolved oxygen and temperature? And use those terms I just talked about, whether they're direct proportional or indirect proportional, and tell me, how is it that you know? How do you know that they're indirect proportional or whether they're directly proportional?
They're indirectly proportionate because when the dissolved oxygen decreases, the nitrate increases.
Well, but this question asks us about what? Did it ask us about nitrates? This question asks about dissolved oxygen and what?
Temperature. As the temperature increases, the dissolved oxygen decreases.
So as the temperature increase, so as I increase the temperature of, so let me ask you guys this. So what do you guys think we're dealing with? All right, this is also something they may ask you because it's something that's not given to you. So what kind of environment do you think we're dealing with? You talking about temperature, dissolved oxygen, nitrates. Where do you guys think we're at? Anybody got a check?
In the water somewhere.
All right, it's somewhere in the water. So when you talk about dissolved oxygen, so we're talking about some type of water environment. And so you may get a question that talks about, identifying the environment in relation to this, or it may give you a question that talks about what would you expect the dissolved oxygen to go in this particular lake if such happens. So just being able to identify certain things that kind of give you a little bit of feedback on where you are in terms of environment and how that data represents or relates to that particular environment, right? What is the relationship between temperature and nitrates? So between temperature and nitrates, what is that relationship? What is the relationship between temperature?
Directly proportional.
Right. Why would you say that? So don't just tell me that. So tell me, how do you know? Prove it to me. So we find temperature, we find nitrates. What happens?
Because as temperature increases, nitrates also increases.
Exactly. All right. And this last question on this particular one says, if the temperature were to be risen to 22 degrees Celsius, would the pH and the dissolved oxygen and the nitrates increase or decrease? So we ask them all three of those. So if I was to increase my temperature to 22 degrees Celsius, what would you expect to happen to the pH? Let's start with that one. So if we increase the temperature.
Increase.
All right. All right, so you said increase. You said increase.
Yes.
All right. Let's follow patterns, right? So we start off high, then we go low, right? Then we go high, and then so what should be the next trend?
Low.
Low, right? So we're talking. Whoa. All right. So we're talking about this. So this is 6.5. So we're talking about 6 point on the pH scale. What does the pH scale go to? What is pH? Tells us how acidic or how basic something is, right? Hello?
Yes.
All right. And the pH scale goes from 1 to 14. All right. And we say that from 1 to 6 is acidic. All right. And we say that 7 is neutral. And we say that 8 to 14 is basic. All right. So the closer you are to 1, the more acidic you are. All right. The closer you are to 14, the more basic you are. And the closer you are to 7, the more neutral you are. All right. So let's look at the trend. So for the first one, are we more acidic or less acidic?
Less acidic.
All right. So we're getting closer to being basic, right? So we become less acidic, right? Let's look at the next one, right? So what happens to my pH here? Do I become more acidic or do I become less acidic?
More.
I become more acidic, right? Now when my temperature increases again, do I become more acidic or less acidic?
Less.
All right. So the next trend should be what?
More.
All right. So you see it's a pattern. So it didn't give you information about that, but it acts about that pattern, right? Let's talk about the next two. So the next two, because we've defined 2 and 3, this should come pretty easy. All right. So it says the dissolved oxygen. So as the temperature increase, right, what will happen to the dissolved oxygen?
It would decrease.
It will decrease. And that'll be a question you should not have to go back to the graph. Why? because you've identified that the relationship was indirectly proportional, which means as one increase, the other one's going to decrease for oxygen, right?
Yes.
Yes, maybe so. All right. And then what about the last one for the nitrates? Should it increase or decrease?
Increase.
All right. Good job. All right. All right. So when we look at the data representation section, so there's a text for each of the passage, and it's usually in a technical language. And a lot of kids, oh, I can't understand the language. Listen, do not be afraid of the language. A lot of information is going to come from those graphs. All right. And so the terminology that I'm using is the terminology you would generally see. And I think by exposing you to that terminology, it makes you a little bit more understanding, a little bit more applicable to understanding it when it comes around. And it's just like the English section, the English section there. You guys are gonna hear words that you're like, oh man, what? But they're generally synonyms of things. I'm pretty sure in the English aspect, I'm pretty sure Miss Hell and them, they're giving you guys different words that are synonyms of one another. It's the same thing across the board. We found things that don't get tripped on the words. It's semantics, right? I can say grotesque and I can say nasty. They both mean the same thing, right? So because of the language is so complex, refer to the figures and then look at the question. So look at the scan the charts and then go to those questions. All right. So very few of the data representation answers will be found in the text, right? A lot of information is not going to come from the text. So there's no point of reading the text. So that's why I say, look at those graphs, analyze those graphs real quick, and then go look at those questions. Boom. All right. That's a great time saver. All right. When you have a test that has a lot of questions in a short amount of time, and it's some reading involved, that tells you, like example on the reading test, right? That tells you, most of those passages tell you to go look at a particular part of the reading passage. Agree or disagree?
Agree.
All right. So so when you have something that's set up, well, I'm going to give you 35 minutes, answer 40 questions. Like, man, that's kind of impossible. Well, the reason why they do that is because that is in itself saying, okay, most of the information is going to be in a place that's easy to find. And in science, there's nothing easier to find than reading those graphs, right? And so figure out a way to take the graphs you're looking at, because of those graphs is what you're going to use to answer the questions. And unfortunately, it's going to require verbiage on the analysis aspect of it. And so what you want to look at, you want to figure out a way to make sure you can have your graphs converted to some type of systematic sentence for you to understand what's going on. So if I see that my numbers are increasing and one factor is increasing, others decrease, I say, okay, that's an indirect proportional relationship. So I know something's going to increase and decrease, or something's going to adversely affect the other entity. All right. And so also determine the purpose of the method of the given information. So what is the purpose? What are we trying to figure out? How does this relate to the overall data analysis of the representation of the data? All right. Any questions, concerns, comments, or remarks so far? All right. So conquering data representation. So before we're going to look at the questions, look at those charts and everything like that, become familiarized with those charts and those variables. Listen, don't go read the text prior to the questions, right? If you need more information, the questions are going to tell you in passage 2 or in passage B, an experiment is going to refer you to where to go and look. All right. So take advantage of those time savers there. And remember, like most of the questions are going to conquer on this data representation are going to come from the charts. This is the easiest section to answer in the science aspect, because all the questions you need, all the answers you need, are gathered from the data tables, the charts, and the graphs that are presented to you in the experiment. That is the easiest information to come up with. So you want to make sure you look at the charts to have a general idea, of, whoa, go back. To have a general idea of what you're dealing with. And so things you might want to ask yourself, like, are the charts in a logical order, right? So does it make sense? Does the flow of how they organize it, does that go sense? What specific items are in each of the charts? So what is the charts information giving to you? And how does that kind of sort of relate to the overall aspect of the question? All right. And how are the various charts or the graphs linked together? So how are they different? how they're the same, what is consistent, what is not consistent within those graphs. All right. So I'm going to stop sharing. I'm going to open up the exit ticket for you guys. Oh man, somebody got, I'm sorry. I didn't know you was in the waiting room. How long you out there? And it was Chase. So let's go to let's look up our exit ticket. All right, guys, do me a favor. Go ahead and open up the exit ticket. I'm sure what it looks like. So go into that Google Doc forms. I've created an exit ticket for you guys. Are you guys seeing my screen?
Yes.
Yes.
All right. So
Yeah.
go ahead and open up the exit ticket for me really quick, ladies and gentlemen.
Where do we open it from?
It's in Google Docs. So in the Google Docs on the cap and gown. Let me see you guys. Let me pull up this thing for you guys. This is I'm not used to using Google Docs, so I'm not a tech savvy person.
Miss Heller usually
use,
sends like a link in the chat. I think it's, if you go up one more, that might be it.
This one here.
Yeah. Could be wrong, but
All right, there you guys go. And whoever there was that got kicked out, did you get back in? Thank you.
Yes. Thank you.
Okay, you're welcome. Listen. Let me tell y'all, I'm old school, so I'm not a texter. So just y'all gotta like communicate, because I just not looked at the chat, so I'm sorry about that. So definitely use your words with me. I know you guys have your microphones muted, and so you want to unmute those, and it makes easy access. Because for my virtual class, my kids have to have their microphones unmuted and the videos enabled, because that's just the type of teacher I am. I can't look at a screen. So I thought you guys could, that's why some people want to respond. You guys are muted. I didn't know it was said like that. So do you guys all have that? Do you guys all have the exit ticket link?
Yes.
All right. Go ahead and complete the exit ticket. And if you want to hang around for office hours, that's perfectly fine. If not, then you guys are free to go. We're going to discuss the exit ticket for those that want to get a little feedback on what they responded. If you don't want to get the feedback on what you responded, don't save that. X all that. Hopefully it doesn't X out the meeting. Okay. Are you guys having trouble with that?
No.
Let me stop sharing. Okay.
Did you say we could go once we were finished?
Yeah, unless you want to stick around for office hours, we're gonna do, like, once I get everybody to turn them in, we're gonna kind of go over and discuss them a little bit for the ones that want feedback on theirs. So I have Underwood. I have yours. So that is essentially like the end of the class. So if you just want to hang around to get a little bit of feedback, to get a little more insight, that's perfectly fine. Once you complete the exit and submit it, you guys are perfectly fine. I think that was Darian, man. I think Darian and it was one more person that kept chiming in and answering a couple of questions. It was a female,
Jasmine.
Jasmine. All right, thank y'all so much, Darian and Jasmine. Good job on today's lesson. Thank y'all for participating and definitely and engaging. You guys are definitely gaining a lot from that. Things you guys will understand. Was this helpful to anyone? Or was
Yes.
it stuff you already knew? You guys go and unmute for me. Everybody go ahead and unmute. Let me see if I can ask y'all to unmute. Yeah, unmute. Let's communicate. Let's converse. I can talk to computers all day, man. All right. So is there anything that you guys feel still are not comfortable with, still unsure with? And we're gonna do a multitude of these. We're gonna keep working through these. The science is just like the reading. The more you do, the better you get at it. So practice, 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 what it relates to. I tell most kids to listen. When you talk about the science test, don't be afraid that you may not understand, or you may not have taken certain science. You may not understand all science. That's fine. Think of it as just another reading test. That's it. It's about how well you're going to be able to comprehend what's already been presented to you. That's all they want. So can you comprehend what's been presented to you? And all the information to comprehend that is definitely there to understand that. All right. Hey, Miss Heller. Some of them are completing the exit tickets.
Perfect. I'll be quiet so they can focus.
I didn't know how to send the exit ticket, so Darian kind of helped me through that. I thought they automatically popped there. I didn't know how to send the link. I told him I'm not good at this tech stuff, but I promise y'all, I'm gonna get better, y'all. I'm a young old person, y'all.
They know how to do it. It's all good.
I'm a young old person. All right. You guys have any other questions on data representation? Anything that was unclear? Anything you want to focus on a little bit more? Anything you care to share?
No, but this was very helpful. Because
Yes.
I could not understand data representation, and then after you broke it down, like I really understood it.
So yeah, all it is looking at the graphs, reading those graphs. So data representation, we're going to represent the data. We want to figure out how does this data apply to the numbers, the trends. So everything is there. So how many of you guys prior to that, how many guys focus on actually reading those passages in the data representation?
Me.
You did, yeah. So that it's a waste of time. So you may out of the 5 questions, there may be one question geared towards something you have to read. But generally speaking, most of those questions are geared towards you analyzing the data that is there. How many guys learned how to effectively read graphs today?
I did.
Yes.
Same.
So graph reading is something that a lot of kids kind of find troubles with because I guess in science it's the first time that you actually apply the things you've done in math into a graph and like, oh, well, that's what that means. You know, who knew that slope was, I can look at a line and figure out the slope, and that slope is going to be generated to identify that the aspect of the quantity we're dealing with. In terms of identifying that, if I talk about rise over run, we always hear rise over run, and that is slope, but we don't always hear how to apply it to the science aspect and being able to identify the relationship thereof. What about, how do you guys feel about interpreting data from the graph when there's no points there and it's asking you to make an assumption? You guys feel a little bit more confident on that aspect?
Yes.
All right. So how did you guys normally approach those situations? Just out of curiosity.
I
I would
guess.
try to read the text and see if it would tell me, but I will always run out of time.
Yeah. So and remember, so like the science section, it is designed that way. And think about it. A lot of the things on a lot of standardized tests are simply tricky, right? You know, I tell kids, don't read the directions. You know why? The directions change. The directions tell you to read the questions and pick the best answer that applies to the question. Agree or disagree?
Agree.
So why wasting time reading the directions? Those are things. Those are time killers. They're put in place to kill your time. The ACT, listen, it's a strategy test, y'all. All right. So if you strategize, you'll do well. All right. So yeah, I'm not saying you can not know anything. You have to know some things. And you have to be able to understand certain things. But really, if you know enough to strategize, you'll be very successful on ACT. All right. So it's about strategy. So I'm teaching guys the strategies to be successful.